Archimedes' principle states that an object immersed in fluid experiences an upward buoyant force. The buoyant force is equal to the weight of the fluid that the object displaces. When the buoyant force equals the weight of the object floats. If the object's weight exceeds the buoyant force, the object sinks. Buoyancy is why large ships made of steel can float despite steel being denser than water. The principle of buoyancy is crucial in the design of submarines, allowing them to control their depth. A solid steel block sinks in water because steel's density is greater than water's. A ship floats due to its hollow shape, which displaces a large volume of water. The ship's hollow design reduces its overall average density, making it less dense than water. Buoyancy is achieved when the weight of the water displaced by the ship equals the ship's weight. The ship's large volume and air-filled compartments are key to achieving a lower average density than water. A ship floats at different levels depending on the density of the water. Seawater is denser than freshwater, with approximate densities of 1,025 kg m3 and 1,000 kg m3, respectively. The ship displaces less seawater than freshwater to achieve the same buoyant force. In denser seawater, less volume needs to be displaced to equal the ship's weight, resulting in a higher floating position. In less dense freshwater, the ship must displace more water to generate sufficient buoyant force, causing it to float lower. Approximately 90% of a ship's volume is typically submerged below the waterline. Only about 10% of a ship's volume is visible above the water. The proportion of submerged to visible volume depends on the ship's design and its load. The submerged portion of the ship provides the necessary displacement to balance the ship's weight, according to Archimedes' principle.